Hi, I'm Khalil, and this is my review of the accelerometer app. This app is free on the Apple App Store, and it collects data from the accelerometer that's inside of your phone. This measurement can be done with any iPhone because all of them have an accelerometer built in. So the way that the accelerometer inside of your phone works is that there's a micro electromechanical system, otherwise known as a MEMS unit. This contains a proof mass. I drew a little thing here. The proof mass is the thing in the middle, which is free to move in one direction. Like in this example, it would go back and forth, side to side. And a bunch of electrodes, which are the little nubs here, that are fixed to something. Those don't move. So the sense fingers, the little protruding parts from the proof mass, the proof mass and the electrodes are charged. So the sense fingers create a capacitance between them and the electrode. So as the phone accelerates, the proof mass moves in the direction in the axis that it is free to move, and it creates a differential capacitance on one side and the other of the electrode. So that differential capacitance is measured, and so it turns physical movement of the proof mass into electrical signals, which are then amplified and then converted to a digital signal for your phone to read. Inside of your phone, there are 3 of these units, one for each axis, so it can measure the linear acceleration in up, down, side to side, and front to back. So your phone uses these every day to track your steps on the Health app and the Balance app if you need to see if something is aligned. And whenever you tilt your phone to turn something from portrait to landscape mode or vice versa, it uses the accelerometer app to see which way it's pointing, which way gravity is. Yeah, and all of that's done automatically because of the accelerometer built in. This app is quite simple. It is everything that you can do, you can see on just one screen. So you can see this is it. The only thing is if I scroll down, there's a little ad, but we don't have to worry about that. So you can see that at the top, there's a rolling graph. At the bottom, the units are every 2 seconds for the x-axis and a G scale on the y-axis. So the y scale is variable. Right now it goes from -4 to 2, but if I were to shake it around quite a bit, it's now from -10 to 10 because it's shrunk to fit everything in that area. And then once all of that passes back to the screen, now it's back to -2 to 2. So it can change around there. And then you can see that on the bottom right, there's a little diagram of your phone, or of a phone, that shows where the axes are in relation to it. So because it shows the origin for these axes being directly in the middle of the phone, I'm using that for the experiment that I'm going to do a little bit later. And then finally, next to that diagram, you can see that it shows you the exact values of the acceleration, in G's. So, and those are all given to 6 decimal places. For the experiment, I made a little device to hold my phone. I threaded string through the sides of a box so that it could be swung around. For simplicity, I will keep the box flat on a surface so that the centripetal acceleration will be completely in the y direction. To calculate what the expected centripetal acceleration is, I will use the formula that centripetal acceleration is equal to v squared over r. Velocity will be very difficult to measure, so instead I'll substitute 2 pi r over t because the radius and period are much easier quantities to measure. After substituting and simplifying, we get 4 pi squared r over t squared. The period measurement for this trial was taken by finding the 10 most consistent rotations, finding the time it took to complete those 10 rotations, and then dividing that time measurement by 10. The radius of rotation was measured as 25 centimeters, which takes into account the 30 centimeter long distance from the end of the string to the center of the phone, and then seeing that the rotation is a little bit smaller than a radius of 30 centimeters, and I measured that to be about 5 centimeters less than that, so 25 centimeters. So the overall expected G-force would be 1.59 Gs. And then the experimental from the app, it told me that it was 2.07, and this was found by averaging all of the values that it spat out over the about 7 or 8 second long window. This corresponds to a experimental error of 23%, but this is definitely within the realm of possibility with all of the inaccuracies that happened during the experiment. The period for this trial was calculated in the same fashion and was determined to be 0.899 seconds, and the radius was 45 centimeters. This led to a calculated centripetal acceleration of 2.24 Gs, or 21.98 meters per second squared, and experimentally determined as 2.54 Gs, or 24.9 meters per second squared, and that's through the app. And this led to an error of 11.8%. As far as accuracy goes, I think that this app is pretty good. The fact that it is part of the hardware of the phone and it's just taking data that is being produced anyway, I honestly trust the output from that app more than the calculations that I made, because the calculations were based on measurements that had some degree of uncertainty, actually quite a degree of uncertainty, especially because the circle that I was spinning my phone around was a little bit smaller than the string, and there was a lot of friction between the ground that could have caused other things to happen. So overall, I think that the accuracy is quite good. Moving on to pros and cons for this app. Number one, it's accessible. That's for two reasons. Number one, it's free on the App Store. And two, you can use it with any iPhone because it's a built-in hardware thing. So if you were to something else, like if you wanted to make a 3D scan of something, obviously a very different thing. But if you wanted to do that, you would only be able to do it with the iPhone 12 and newer, because those are the only ones with LiDAR capabilities. But I had an older phone, and that didn't stop me from getting this app. Next, it is simplistic and readable. Everything's on the front page. No need to mess through menus or settings or anything. It works and it's accurate. Again, it's part of the hardware of the phone, so it should be accurate. It's Apple after all, so they don't mess around with their engineering. And then, yeah, that's it for pros. And then for cons, there is no total acceleration. That's one of the issues. Like for some other apps, like I think Physics Toolbox, they have a similar thing, and they have a total acceleration thing where they take all the components and sum them together with the Pythagorean theorem, whatever. It's very easy for them to implement, but they don't do that. It's only the X, Y, and Z components. You'd have to stick those components together by hand, which would be a big hassle if you wanted to do something like what I did, which added in a bunch of the data points over a long period of time. And so I only had to do that over one axis, but if I had to do it over multiple, I would really want a total acceleration data point, but they did not have that. The graph can't be interacted with, recorded, or frozen at all to look further into one section. You'd have to screenshot it, and it doesn't have great definition. The graph is kind of just to show you what's going on, not to actually make any measurements from. It is always going on in the background also. That's another con. It's not particularly taxing for the battery life. But if you don't clear it from running, then next time you open it, the graph will say it's been going for like 10,000 or 40,000 seconds. And it's hard to read that axis entirely because there's so many digits and they kind of get cut off. Another con, it has ads. They're not very intrusive. I know some other apps, they'll have ads that pop up and take up the entire screen. This is just something on the bottom that kind of pokes into the screen, but you'd have to scroll down to see the whole thing. So not too much of a con. And another one that's kind of just a nitpicky con, not really that big of an issue, is it's all in Gs and you can't change it to meters per second squared. So the SI units are harder to get. You'd have to it's just dividing or multiplying by 9.81. So it's not that big of a deal, but does make things a little bit of a hassle. Okay, and then my final rating for this app, I'm going to be doing it over 3 categories and an overall score. So for accessibility, I'm going to have to go with 5 stars. No complaints there. It's free, can be used with any iPhone. For accuracy, I'm going to do also 5 stars. Again, it's part of the hardware. Apple doesn't mess around. 5 stars. And then usability for experiments and such, I'm rating this actually 1 star. And that is because in order to get the measurements that I showed in the experiment portion of this video, I had to go frame by frame and analyze each of the data points that it gave me for the y-axis, and then I put it into my calculator, so over 100 data points, and I had it run a statistics analysis for me in order to find the mean. So I had to do all of that work myself. The graph is not really useful for experiments, and there's no total acceleration. And I think that was the most important category, so unfortunately for this app, it's going to go with 2 stars total. If you want an accelerometer, use Physics Toolbox. It's just better.